Hi, welcome to this new video. My name is Sergio and I help companies, students and freelancers to easily and efficiently build visual recognition projects. As you can imagine, and you saw that from the preview, we're going to see right now how to make facial recognition. So let me explain a quick difference. One is face detection, where you just surround any face with a box. And then there is second, what we're going to see today is facial recognition. So it means surrounding each face with a box, but also telling exactly who that person is. So putting a name on that face. Of course, we start from some database of images that we have from specific people. We'll see that on an image and also on a video and in real time. So let's start. Before we start, you need to know that you have to download some files from my website. I'm going to put the link down below and you need to get these files. So we have images, of course you can get your own images. I have some simple images, main.py and then simplefacerec.py. This is really important, don't miss this step because you're going to get an error later. Second, we need to install two libraries. How do we install the libraries? We go on the terminal, command prompt, cmd, and we see command prompt. Whether you have the Mac or Linux is the same. You open the terminal and you need to type pip install Opencv. Python is the first library. And anyway, all the things that I'm saying right now, so all the commands will be also that on my blog post if you just want to copy and paste them. Pip install Opencv-Python is the first one. You press enter. I'm not going to do that because I have already the library. Then pip install face underscore recognition. And then you press enter. And we're going to use this library, which is called face recognition, which is a great library that simplifies all the steps. This is the GitHub page. I will not go into details about this one. I will leave also the link for this because I want to make things very simple right now and easy to follow. So this is a great library developed by Adam Getgay, and we'll use this one. Let's start right now. So I'm going to start with an empty file. We're now going to import CV2, which is the Opencv library, and we're going to load an image. So let me explain what's the idea. Now we load a simple image. For example, I'm going to load messy1.webep. We load this image, and later we are going to compare this image with other images. So to check if we have messy somewhere on these pictures. So if we have messy, the algorithm should tell us, yes, it's messy also somewhere here. So let's do that. We load, first of all, img equals, to load an image, we use cv2.imread. And here we need to put the path of the image. I have that on the same folder, messy1.webep. And now let's display the image, cv2.imshow emg, and then emg. I forgot something, imshow. Now, this will display the image, but we need a wait key event to keep the image on hold. So cv2.wait key 0. So it is going to wait until we press a key. I'm going to run this right away to make sure that everything is correct and that we don't get error. It works. This is messy. Now, what is the first step for face recognition? We need to encode this image. So the algorithm will encode this image so that later it can compare the face of Messi with other faces. There is one step before, so we need two lines. One is we need to convert the image format from BGR to RGB. Opencv by default uses the BGR format. So blue, green, and red, and we need red, green, and blue. So we need just to swap that. So RGB EMG equals cv2.cvt color. So convert color. What do we want to convert? We want to convert EMG. Then cv2.color underscore BGR to RGB. We're going to convert the BGR format to RGB. And now we're going to encode the image. So we will say EMG encoding equals. To do this, we need the library face recognition. We're going to import face recognition, and then we'll say face recognition dot face encodings, and we're going to put here RGB EMG, and then we're going to say 0. So probably because this loads multiple image, can load multiple images, we're going to use just 0 here as an index. We have the first image encoded, so let's restart this. I'm going just to restart to make sure that there is no typo and I don't get any error. I run this quite often to avoid to have a lot of code and then it's a mess if you get some error. And of course, it's a bit slow when you have the encoding because it needs to analyze the image. The bigger the image, the slower the encoding is. And this image is quite big. It works. Let's go to the next step. We're going to do exactly the same process for another image. I'm going to copy and paste, and we just are going to change. We will be changing only the variable's name. So we have, let's load the second image. We're going to load another person. Let's load Elon Musk. So I'm going to load EMG2. cv2.imread. I have Elon Musk on another folder, images. And then Elon Musk. By the way, everything that I am typing here will be on the link in the description. There will be a blog, all the code you can download, everything that I have, and also the test images that I am using. So images, Elon Musk, JPG. So RGB EMG2, EMG encoding 2, face recognition, RGB EMG2. Okay, that was quite simple. And now let's display also EMG2. So now I'm going fast just with this example, but later we will use this in real time and it will be, the code, it will be much easier. I have another file which have this really simplified. So don't worry if it's hard for you to follow. There is not much really to understand. It's just a few lines. Now we need to make the comparison. So what is the idea? We have EMG encoding 1 and we have EMG encoding 2. We want to know if EMG1 and in EMG2 there is the same person. So let's do that. Result equals face recognition dot compare faces, and right here we're going to put first EMG encoding and then EMG encoding 2, and let's print the result. Let's run this one. This might take a few seconds to run. So what are we doing? We're comparing this image, Elon Musk, with this image of Messi. And the code should tell us true or false. If true, if it's the same person, or false if they are different people. And the result is true, which is a bit awkward. Okay, I just realized that there is some typo here. So I'm loading EMG1 again. So EMG2. Of course, they are not the same person. So I was surprised, to be honest. So let's run this again. By the way, this algorithm is really precise. This worked great. It has like 99% accuracy on some data sets. So if you're getting an error, it's most likely that there is some type of mode and it's not working well somehow. So we have a result, now it's false. So we're comparing this one with this one, and of course, they're not the same person. And we see result false. Now, let's test also with some other image. So we're going to compare Messi with this one, Jeff Bezos. Jeff. Okay, we're going to compare Messi with Jeff Bezos. Jeff Bezos.jpg. So of course now we should get again false. It takes a few seconds. It's of course a bit slow. You might even, there is some, it's more complex installation, but you might get this working with a graphic card, media graphic card, and it will be much faster. Again, we have result false. I'm going to make the last testing, so we're going to compare Messi with another picture of Messi. So now we have Messi, Jeff Bezos. Are they the same person? Exactly, they are not. So now let's load Messi and Messi, but of course a different picture of him. It wouldn't make any sense to load the same picture. Messi, WebEP, and now we should get true. And we get result true. So we are comparing this one with this one. So despite is on a different environment, despite also the lighting, the color, it works great. We get result true. I can say that this one honestly was quite simple to achieve. Now it will come the fun part of the project, where we're going to have a simple code to run this in real time, and I will be using my webcam. So let's do that. I'm going to store this somewhere so that I will put later on the blog. So you will get also some file with this one, while I'm going to start this from scratch, but in real time from a video. So we import CV2, we import face recognition, and now we import from simple face rect, we are going to import simple face rec. Keep in mind, this is not a library, this is a Python file that you need to download from a website and put together on the same folder with the main file. Otherwise, you get an error. So let's run this one. How do we work with a webcam? First of all, we're going to get the stream from the webcam, and later we will do all the rest. So first of all, let's load the camera cap equals cv2.video capture. Then we put the index of the camera. So load camera 0. So this is say load the first webcam. If you have multiple webcams, you need to put 1 to load the second, 2 to load the third, and so on. And I have 3 cameras, so I need to load the latest one. So I'm going to use index 2. Most likely you will need to use index 0 if you are not using the webcam, you have just one. While true. Now we're going to get the stream in real time. So in real time, we're going to get frame after frame. Ret frame equals cap.read. So ret is true or false. True, we have the frame. False, we don't have the frame. And frame is the frame. And now let's show the frame. cv2.im show frame and then frame. And now again, as before, a wait key event, but this time slightly different. Key equals cv2.waitKey1. Before we had wait key 0, which was freezing the frame until we will press some key. Now we say 1, so waits 1 millisecond and go to the next frame, so that we have the video in real time, or like the camera in real time. But if we want to quit, we can do that. If the key is 27, which corresponds to the S key on the keyboard, this breaks the loop. Finally, we need to release the camera cap.release and cv2.destroy all windows to close all the windows. Let's run this one. So I'm going to run main.py, stop and rerun. If everything is working correctly, we should see the live stream of the camera. So we have the camera loading. Now it's not doing anything, just displaying the camera. Let's now use the library face, simple face rect, not the library, the Python file simple, the module simple face rect, to compare the faces. How do we do this? First of all, we need to load the encoding faces. How do we load that? So also let me explain. I'm putting too many things and not being clear. We load the encoding faces. It means these are the known faces. So later we will look wherever we have for these people: Elon Musk, Jeff Bezos, Messi, Ryan Reynolds, and me. So each time we see one of these, we will get their name. When we see some other face, we will get a known face. So that's the goal, the idea. So let's encode all these faces together. So for this, I created a simple function which imports all the faces that are on a folder. And we need to do this: encode faces from a folder. First of all, let's initialize the simple face rect module. Simple face rect, let's call SFR equals simple face rec. So I'm going to initialize this. Then let's load, I will put this before loading the camera, like this. Now let's encode all the faces, all the known faces. So we will take the path where they are. So I will put them just on images. And we do this: SFR dot load encoding images. And right here, we need to put the path of the folder. So we have them just on images. So this is the path where all the images are. To make sure and to show how this works, I'm going to run this. If everything is working correctly, you will see an output that 5 images were found because I have 5 images. Of course, you can put how many images you want in that specific folder. So you can put your own images, how many you want, whatever you want, just put them here and they will be automatically added to the encoding. Now let's go to the next step. Once we have 5 encoding images found, just after we get the frame, we are going to detect if any of the names are there. Detect faces. So we use SFR dot detect known faces, and then let's from the frame. What are we going to get in exchange? We're going to get the face rectangle for each face. So we're going to get face locations, and then we're going to get the names, face names. By the way, if we're wondering how are the names loaded if we're not putting the name anywhere, they will be taken from the image title. So for example, this is the image of Elon Musk and it's called elonmusk.jpg, Jeff Bezos.jpg. So the name that you put on this image is the name that you will see displayed later on the screen. Face locations. So let's now first of all display the face locations. For face lock and for name in zip. So we're going to extract these together, face locations and face names. Let's first of all print face location, face lock. And let's now run this one to see what we get. So now the idea is that we're going to get face location, so of course the coordinates to display correctly the face in real time on the frame. And right here you see that I have a lot of outputs, and even if I move my face, you can see that these numbers somehow are changing. All of them, okay, now all of them. Here we have the location of the face. So what I am going to do right now is I'm going to take these values, I'm going to extract these values and draw a rectangle surrounding the face. So now I don't have anything, we should draw the rectangle using these coordinates. What are these coordinates? There are 4 values. The first two is the top left point, and then we have the right bottom point. So top left, like this, top left, right bottom, and we have the rectangle of the face. So we have top left, bottom right equals face lock 0. So I'm going to extract them one by one this way. Face 1, face 2, and face 3. So I simply assign to the first value is top, is the y, the second value is the x, left, then we have bottom, and so on. Now let's draw a rectangle for this one. cv2.rectangle. We're going to draw the rectangle where? We're going to draw the rectangle on the frame. So frame, then we have x and y, so we have left and top left point. Then we have point 2. Probably it's better just to call this with the coordinates, it will be less confusing. So instead of top, this will be y1. Instead of left will be x1. Instead of bottom will be y2. Instead of right will be x2. So we have left, which will be x1, top will be y1. So this is just basic geometry with the coordinates. Then we have x2, y2. And now the color, let's make this somewhat red. So 0 of blue, the color go from 0 to 255. We give 0 of blue, 0 of green, and let's give 200 of red, so that it's red but not too bright. Thickness, let's make this 2 pixels thick. If everything is correct, we're going to see a rectangle surrounding the face. We have the rectangle, so red rectangle surrounding the face. Let's now take the name. So the rectangle is working. Also, I will make maybe a little bit thicker, let's say 4 pixels. And let's now take also, so we have the name associated to each face location. Let's display that. cv2.put text. Let's put the text on the on the frame. The position of the text, let's say we're going to put the text on the top of the rectangle. So we will do x1, y1, minus 10 pixels, so that it's not overlapping with the line of the rectangle. So that's why I'm going to say minus 10 pixels. I forgot the text. So first we need the text frame, then name. Here we show the name. So text font face. Now the font cv2.font underscore Herschel. It doesn't really matter the font that we choose. And the size of the text, let's say 1. Color of the text, let's make this completely black. 0, 0, 0. And thickness of the text 2. And now let's run this one. And here we have this in real time. You see there is my name, so it's already a good start. Only I believe I mixed somewhat the coordinates. So my name was supposed to be right here on the top left of the rectangle, so I messed with the coordinates, so I'm going to fix that. And also I'm going to use to make the name a better looking right here, so let's quickly do that. So I mix the coordinates, so we have top right, so this is x2 and this is x1. Probably we have top, right, and then bottom and left. I don't know why they choose to use this coordinates format for the face rect library. It's not common, but anyway, this is how you do it. I was saying Okay, this is, let's make the text look better. Okay, I don't want to take much time with this video, so I want that it will be more clear. So we'll say also for this one, red around 200. So ideally I was thinking about putting a red box and white color of the text, but I might add that code later. I want to make this as simple as possible to get the important information. So how to make the face rect, how to get the face, then all the rest, changing the colors, the shapes. It's all about simple operations with Opencv, which won't make any sense to do right now. It's working right now, so you see now there is my name on it, but I have to prove you that it's working well. So I have the phone and I'm going to show the pictures. Okay, even let me increase the lightning so we will not have any problem. Okay, you see Ryan Reynolds again. Sometimes if it doesn't recognize the person, says unknown, but it works quite well so far. Messi. Can we get Messi? Messi, yeah, it's hard because there is the reflection of the lightning. So Elon Musk, we get that. So the hardest right here is face detection because of the face is really small and the lightning, but normally it will work much better. And again, Jeff Bezos. So this is all for this tutorial. I hope you enjoyed this tutorial. Of course, there are improvements that you could make. For example, you could improve the accuracy. You could improve the speed installing this with the GPU. You could improve the detection in adding multiple datasets. So instead of adding just one single person for encoding, you can add multiple person, for example, for Messi, multiple pictures of Messi, and so on. Let me know what you think about this project in the comment. Let me know if you tried this and what projects are you working on, and questions, because I will take the questions also to make new videos and to improve the projects regarding face recognition. I suggest that you subscribe to get notified, because I will be releasing a lot of new content regarding face recognition, computer vision, and so on. So this is all for now. See you in the next video.